Hey there guys, we're going to go through a whole bunch of slope-intercept linear ideas from Algebra 1. This section and the next section actually cover almost all of an entire chapter of Algebra 1. So take your time down memory lane here. Remember, our equation for slope is the change in y over the change in x. That change meaning that we're going to subtract those. If we forget anything, go the whole way back and think about probably about 8th grade when you first saw some of this, and it's rise over the run. Which axis does the rising? Well, that's y. So that's the y-axis. So that's what has to happen. Just to remember, we can't divide by 0, so if that turns out to be 0, we have to call that something else. So we're going to review that. What's the slope of the line that passes through the points? So we're just after slope. So I'm going to start with my y's, 7 minus 4. Okay, so the key is if I start with 7, I have to start with -3, and that's minus -2. All right, so I know that this is going to be 3 on top. This is -3 plus 2. So I get 3 over -1, which is -3 to get the slope. Right? That gives me m for slope. So that's all we need with that. Okay, so we're going to run into one of those, and then we'll just make up some ordered pairs for the next one. So how about 2, 5, and 2, 12. Let's make it -12 for the fun of it. Okay, so remember consistency counts here. So if I start with -12 minus 5, then I'm going to go ahead and start with 2 minus 2. All right, so I made this happen, right? We're dividing by 0. So what do we get? 0 or undefined? And remember, this is something that's not really doable. I can't have 17 of something and divide it amongst nobody, so that's undefined. So if we advance this idea from Algebra 1 pretty quickly, I want you to take a look at the ordered pairs. And this is going to give you a shortcut in the future to writing the equation. So what I'm highlighting is the x values because they happen to be exactly the same. So what's that mean? So that means I'm going to get an undefined slope. That's number 1. Number 2, that means my equation is going to be x equals, because these were x values, and it's going to be equal to 2. So when we get to the point where we're writing equations, we can get that right away. So if you see repeated x value, we know it's going to give us undefined slope, and we also know it's going to give us x equals that number. All right, let's try something else now. How about -5 with -2 and 11 with -2? All right, so -2 minus -2. And I'm going to start with -5 minus 11. We could have that flip-flop, but then you double side. So we got 0 over -16. This one turns out to be 0. So that's completely okay. Now I'm going to highlight again to, again, give us a shortcut to writing this equation. And that's simply going to be y equals -2, because that's also our y-intercept. All right. So would it be wrong to write y equals 0x minus 2? No, but what's 0 times x? So we're going to end up right back here anyway. All right, so that's just our slope review, so make sure you are consistent, right, in what you start with. Okay, so when I started with 7, I had to start with -3. All right, quick review, positive slopes. We're looking left to right, just like when you read a sentence. Okay, that means it should be going up. Negative slopes going down. 0 slope. Okay, so what would we just find out? 0 slope, that was a y equals. Okay, so this is 1, 2. This is y equals 2. That undefined slope. Okay, this goes through the x-axis. So it's an x equals 1, 2, -2. Okay. So we want to make sure we fast forward to some of those ideas. All right, intercepts. This is an x-intercept. How do we know that? Well, this point right here is 4, 0. Well, an x-intercept is when y equals 0. A y-intercept, like this one here, this is 0, -2. A y-intercept is when x equals 0. Okay, that's going to be super important when we deal with things in standard form. We're just going to find intercepts. I don't want to rearrange it or do anything fancy with it because I want to get things right, number 1. I want to understand what I'm doing, but I also want to work the best way that I can. Right? If I had to take the tire off my car because I got a flat tire, I wouldn't use a screwdriver. Could I do it? Yeah, but it would take forever. So I don't want to do that. We want to make sure we're using the right tool for the right job here. We're going to write the equations in slope-intercept form is our next task, and I think you're up to it. The idea is to solve for y, get y all by itself. Right? So let's get rid of 5x by subtracting it. So negative 4y equals negative 5x plus 16, and divide by negative 4. I'm going to make this look like what's called a complex fraction. I'm going to show each term divided by that. So negative divided by a negative is positive, 5/4 x. Positive divided by a negative is negative, and 16 divided by 4 is 4. So now we're in slope-intercept form. Okay, quick review, we found the slope is 5/4. B is negative 4, right, the y-intercept. All right, let's take a gander at the next one. Oh my goodness. Do you guys like fractions? Do we like that? All right, what have we learned so far this year? How can I fix this problem? First thing I can do to fix it is multiply it all by 4. Because if I do that, I don't have fractions anymore. Could I still have a fraction in part of my answer? Sure, but I don't have to work with it right now. So this is the power of clearing those fractions. We spent some time on that so far this year. So the 4's cancel out. So I get negative 3x. What's half of 4? Well, that's 2y, and it equals negative 4. Well, this is a little bit nicer to work with. Even if you don't like math, you agree that this is nicer to work with. So we're going to add 3x. So 2y equals 3x minus 4, and divide by 2. And again, I'm going to show it as a complex fraction, 3/2. I like slopes like this, right? That tells me a rise and run. Okay? In science class, you're going to go to decimals because you're going to use it for different reasons. Okay? And 4/2 reduces to 2. Again, we have a slope of 3/2, and the b value is negative 2 as we try and identify what's happening here. All right, one more to go. Nothing tricky, nothing fancy. Add 7x. So negative 4y equals 7x plus 35. Divide by negative 4. So y equals negative 7/4 x minus, you know what, 35/4. If you need to graph it, you might want to change this thing on the end. But this task was what? It was to write it in slope-intercept form. As long as it's written in slope-intercept form, it doesn't matter. Okay? If this were 36/4, we'd reduce it, right? We've already done that earlier. But you don't have to change it just for me. All right, so if we have to graph it, this one looks like what? It looks like it's in standard form. So here's what we're going to do. We're going to draw these little brackets on here to make this a little bit easier to understand. Okay, so I want to go by intercepts because I don't want to rearrange things. If you want to rearrange it, go for it. There's no problem with that. Okay, but I know that you guys can solve this really, really easy. So I took my red bracket right here, and what I'm saying is y equals 0. So I'm finding an x-intercept. So I divide by negative 2. X turns out to be negative 1/2. Where is x negative 1/2? X negative 1/2. Done. All right, for the other one, y equals 1. Well, that was already done. So I plot that point, and all I have to do is connect them. I have graphed it. It didn't say I needed to find the slope, didn't say I needed to do anything else. We're in good shape. Okay, so if it's in what looks like standard form, we're going to use those intercepts. Okay, so there's two separate little equations. Okay, let's try it again. All right, let's go red. 4x equals 14. Divide by 4. X is, now I'm going to have to find this point. So this is 7/2. So that's 3.5. 1, 2, 3.5. See, even if it's a fraction, decimal, it's not that bad. We can figure it out. Negative 7y equals 14. Divide by negative 7. Y equals negative 2. Negative 2. Whoop, there it is. Okay, and we'll connect them. There you go. Okay, so that's graphing it. We're using intercepts to do it. All right, so what we're going to do is identify what's a y-intercept and how does a y-intercept differ from an x-intercept. So give that some thought, and what you're going to do with it. Explain why the slope of a vertical line, right, vertical line, is called undefined. So how does that happen? And then error analysis. Let's find out what your classmate did to find out how they got this thing wrong. Okay, so be careful with that and keep an eye on it. Okay, those are the things you want to make sure you finish up in your notebook before you come into class.